Welcome back to the Rad Tech Drive review. In this episode, we're covering OID, SID, and distortion, one of the easiest image production topics to mix up on the ARRT exam. The goal is to remember what changes image size, what changes detail, and how to avoid shape distortion. This matters because radiographic images are not just about getting anatomy on the detector. We want the anatomy to look as true to life as possible. When OID or SID changes, the image can become larger, less sharp, or distorted. ARRT questions often ask what happens when one of these distances changes. Start with the vocabulary. OID is the gap between the patient's anatomy and the detector. SID is the total distance from the source to the receptor. Distortion means the image does not look exactly like the real anatomy. That distortion can involve size or shape. What happens when OID increases? Magnification increases, recorded detail decreases, the image looks larger, sharpness decreases. When the object is further away from the image receptor, the X-ray beam has more room to diverge before it hits the detector. That makes the structure appear larger, increases OID, also reduces recorded detail, so the image becomes less sharp. This is why anatomy should usually be positioned as close to the detector as possible. Remember, OID up equals image bigger and blurrier. What happens when SID increases? Magnification decreases, recorded detail improves, the image is more accurate in size, beam divergence is reduced. A longer SID means the beam is less divergent by the time it reaches the patient and the detector. That reduces magnification and improves detail. This is why chest radiographs are often taken with a longer SID to reduce heart magnification and improve image accuracy. Remember, SID up equals image smaller and sharper. Size distortion equals wrong image size, caused by changes in the OID, the SID, and the beam divergence. Examples would be more OID equals more magnification, more SID equals less magnification. Size distortion means that the anatomy is represented larger or smaller than it really is. OID and SID are the major causes. If OID increases, magnification increases. If SID increases, magnification decreases. Many ARRT questions are really testing size distortion even if they do not use that exact phrase. Shape distortion equals wrong image shape, caused by poor alignment of the tube, the part, or the image receptor. Types include elongation and foreshortening. Shape distortion is different from size distortion. Here the structure is not just bigger or smaller, it is misshaped. This usually happens when the tube, body part, or detector are not aligned correctly. The two big terms to know are elongation and foreshortening. Elongation versus foreshortening. Elongation, object appears longer than it really is. Foreshortening, subject appears shorter than it really is. The simple rule means bad angle, wrong shape. Elongation makes the anatomy look stretched out. Foreshortening makes it look compressed. This often comes from incorrect angulation or poor alignment between the part and the image receptor. One exam question, they may describe the image rather than the naming the distortion. For example, a chest x-ray. Why is chest x-rays done at 72 inches? The longer the SID reduces the heart magnification. It produces a more accurate image and improves recorded detail. This is a favorite application question. Chest x-rays are commonly done at 72 inches because the increased SID reduces the magnification, especially of the heart. If chests were done at a short SID, the heart would appear artificially enlarged. This is a practical example of how SID affects image size. Pause and answer these before moving on. This is where you train yourself to recall the rule fast. The ARRT rewards quick recognition of these relationships. What happens when OID increases? What happens when SID increases? Which distance increases magnification more, OID or SID? What kind of distortion changes shape? What are the two types of shape distortion? Let's review the answers. What happens when OID increases? OID increases, magnification increases, detail decreases. Number 2, what happens when SID increases? SID increases, magnification decreases, detail improves. Number 3, which distance increases magnification more, OID or SID? More OID increases magnification. Number 4, what kind of distortion changes shape? Shape distortion changes shape. And number 5, what are the two types of shape distortion? Elongation and foreshortening. These are the core takeaways. When OID goes up, the image gets bigger and less sharp. When SID goes up, the image becomes more accurate and sharper. Shape distortion refers to the elongation or foreshortening. Speed round, let's test yourself. Number 1, OID goes up, what happens? Number 2, SID goes up, what happens? Number 3, magnification increases with what? Number 4, magnification decreases with what? Number 5, wrong size equals what type of distortion? Number 6, wrong shape equals what type of distortion? Number 7, two shape distortion types. And number 8, wrong shape equals what type of distortion? Number 1, OID goes up, image bigger, less sharp. SID goes up, image smaller, sharper. Magnification increases with more OID. Magnification decreases with more SID. Wrong size equals size distortion. Wrong shape equals shape distortion. Two shape distortion types equals elongation and foreshortening. That wraps up episode 4. Focus on the relationship between OID, SID, magnification, and distortion. These are high-yield concepts that show up often in both direct and application-style ARRT questions.